Hi everyone, I'm Francis Gorman. This is the Entropy Podcast, episode 5, and I'm joined with Dr. James Merrick, Gal Research. James, how do you do?
Very well, thanks, Francis. A pleasure to join you and join your esteemed list of guests on your podcast.
Thanks, James. It's great to have you on. James, you have particular expertise in the supply and use of low carbon electricity. Um, Quite topical at the moment is the 2030 commitments we made around our carbon reduction in Ireland. We committed to a 51% reduction in greenhouse gases, but it looks like we'll only achieve a 29% reduction during that time frame. Based on your expertise and your observations of this space, we're going to pay a significant amount of money in fines for not hitting those targets. What's your perspective, and can technology play a role in helping us solve these problems?
Thanks, Francis. There's multiple layers to talk about there. Maybe I'll give a word on the Irish context and maybe bring it out to the global context, and we'll come back to the Irish again. I think there's a lot to celebrate in the 29%. That would be one aspect of maybe the news coverage that doesn't get there, because our economy has been really successful. So when these projections are made, maybe there's various mathematical models used, various analyses. Okay, let's assume some economic growth. Let's assume what sort of emissions might be looking there, and then what can we do relative to that? But our economic growth has probably been faster than expected at the time. So the fact that we have reduced our emissions to that scale with the level of growth Ireland has had is quite an achievement. And I think there's quite a lot of positive there. Would be my first comment on the Irish situation. When I first got involved in this area was when I was studying for my master's at the Massachusetts Institute of Technology, and back then it was a real question: could you have economic growth at all without emissions reductions? Like, could they be decoupled? And so the fact that we have seen this decoupling is a big achievement, and globally, it maybe not quite as striking as has been achieved in Ireland currently, but it is So that's the first point, and maybe the other perspective on technology and how it can help us do more. Also, at that time, and after MIT, I had the opportunity to work at the Electric Power Research Institute in Palo Alto in California. A great team there. And we were kind of looking at all these big questions, building models around them. And again, we look, okay, if wind and solar hit certain cost projections, how much of a role can they play in the system? It was quite abstract. We had various pilot projects, a little solar plant here or a wind farm here in California. There was some stuff built in the 80s in California. It was all kind of pilot stage. And now we're in a world in 2010, 2024 now, we're in a world where turbines are now 3 or 4 megawatts each. We could talk about some of the visual aspects there. And the solar power has got so much cheaper. It's a very positive story. Like what I would say from 2010, between 2009, the sort of maybe earlier, the sort of projections was the world was on a course for 6 degrees of warming on the path we were on. Now we're probably on a path less than that. I'm going to just make up a number, 3 or 4 degrees on our current path. Now, people have done detailed analysis of that, but it's better. And we can go more. The Paris Agreement, that's kind of underlying the European and Irish climate goals. We want to hit 2 degrees, and that's there's good reasons for that. But yeah, so I'm quite positive, and I'm quite positive how technology has developed. So that's a long answer, and
when we look at that, James, I suppose Ireland is a speck on the wider map
yes.
of the worlds we live in. We have Burn Baby Burn coming out of the US at the moment. We've bombs and mass levels of destruction happening in Gaza and Ukraine. Are our efforts going to be in vain? Do we need everyone to toe the one tide here in order to actually have any level of success, or are we going to put blood, sweat, and tears, probably pay huge fines, but at the detriment of ourselves because we actually can't enact
Yeah.
change as a micro economy versus the larger perspective of world order at the moment.
It's a great point, Francis, and it's a key point of the climate challenge and why it's it makes it such a sticky problem is that the costs of reducing emissions are here and now, while the benefits are spread over future generations and across the world. And so, um, no country can solve it on its own. Not even the United States can solve it on its own, or not even China can solve it on its own. So I do get a little frustrated listening to in the Irish context sometimes, where I've been lucky to be kind of in those sort of global conversations. And when you come back to Ireland, it can sound very parochial. It's as if we don't hit certain target, the world's going to end. You know, it's we could. I think all the small country can do is because if every small region, every country, big country is made up of small regions. If every small region say, well, we can't change it, so we do nothing, then we end up with a big problem where nobody does anything. So that's clearly the coordination challenge. But I think what a small country can do strategically is show leadership. And so I think the Irish example is actually a good example now of economic growth and emissions reductions. But I think, yes, like this concept of sacrifice, we need to sacrifice, we need to at all costs reduce our emissions. I suppose what I'm really saying is kind of economic self-harm is not going to be an example others will follow. And all we can do as a small country is set a good example.
Economic self-harm. I like that sentiment. And that probably leads me into my next question. We both grew up on dairy farms and are from an agricultural background. The agricultural sector in Ireland seems to be getting a lot of the stick in terms of the lead cause of our emissions. I believe it's over 30% on official figures in that area. Have you got a perspective in terms of that narrative? And if technology or adoption of practices can play a role in helping to reduce that, or if it needs to be reduced at all?
So when I was living in the States and kind of in those climate change, energy system, technology conversations, and then I arrived back in Ireland and some of the all this talk about belching cows, I found it bizarre, that because it's a sort of a parochial issue that we don't have the industrial base. We know that all the economic problems of Ireland in the early 20th century, and so we didn't have this industry. So it's almost a kind of an artifact that we have such a high level of emissions from agriculture as opposed to industry, like other countries have had. So it's kind of, I feel it's sort of a parochial outsized role in our conversation here. You could spend hours talking about the methane cycle and its role in the carbon cycle and biogenic methane versus methane emitted by the extraction of fossil fuels. So it's complex, but I think it is fair to say biogenic methane is different than the extraction and burning of fossil fuels. Maybe a simple way of putting it is like how many cows are natural? So it's how many natural cow if there was no humans in the world, how many cows would be out there belching? And so the argument is, there's humans. We drink milk, so we have more cows, and because there's more belching, that's attributable to humans. So just maybe the big point is there's just a lot of accounting you have to do on the dairy side or on the agricultural side that makes me a little nervous because you make some assumption about the conversion rate between methane and carbon dioxide, and all of a sudden you can be doing drastic actions based on the conversion rate as opposed to based on the actual global climate problem. And so that's the challenge. And I think the New Zealand government has recently done a new report on the methane side that I think I have a lot of time for. I think it's a sensible. Seems to be at a surface level a sensible approach where they just separate methane from carbon dioxide rather than bunch them together. It seems they're going to separate them and deal with them separately, given all the different dynamics. And on the technology side, I think there's a positive story. If you look around the fields, this kind of low emission slurry spreading has become a lot more popular. That's partly a regulation story, but partly an economic story where the farmers get more value out of the nutrients. There's less waste. And I think there's more to come on that side too. A lot done, more to do for a former election slogan that's out there. But I think once there's progress, I think we can be happy and not get too worried. Maybe there's an element that the end of the world is coming. I don't see that. I think a wise person would say, like, if we don't hit 2 degrees, then it's good to hit 2.5 degrees. We don't want to hit 5. So every bit counts. Another thing in the Irish narrative that bugs me is that we are the carbon budget. We were legally is enshrined in law. We're going to break the law if we don't hit it. But at the end of the day, if the government breaks the law, it's not ideal. But what is the redress? And they can always go into Dáil someday and have a one-line bill. We have now increased the carbon budget by 2x, and we're no longer breaking the law. It's a common and old thing in environmental economics, going back to the acid rain, going back to the 70s, is kind of market-based policies versus regulation-based policies. And where an element was, there's an argument, and that I'm sympathetic to, is that the local actors on the ground are the ones with the information. They're the ones who know the value of different activities. And so once they internalize the cost of pollution, then they can make the trade-offs. And so you need markets you need government policy to put a price on pollution. But then you let kind of individuals work things out. But when you're kind of excessively top down, there's just a lot of information the top down decision makers don't know. And so that again can make me nervous, because you can kind of have red tape then drive a lot of economic harm unintentionally.
Very good perspective there, James, and I think it's a conversation we could probably talk about for quite some time and in some depth. But maybe the key takeaway is we might need to separate agriculture from core industrial and take a different metric or measurement against it, whilst understanding the wider scale problems that need to be addressed at a global economic level, not just at a singular level, as you pointed out there. But really, really key takeaways, and I think it's a topic that's going to get louder as we get closer to 2030. So we're 5 and a bit years out now in terms of that drop dead date. I would like to see more inward investment rather than outward fine paying activity, if that makes sense. So I think if we're going to do something about it, we should do it for the betterment of society, do it as that thought leader, as you said earlier, and not just throw that money away in fines at the end of the day.
Yes, and I'll have to read that report that came out this morning as we spoke, from the Fiscal Advisory Council and the Climate Change Advisory Council, because the fines, it's there'll be a lot of politics around those fines in 2030, whether they happen or not, and maybe there's an element where they're going to be ring fenced for low carbon investments. So it's hard to know the ins and outs of it, and are we going to be, I suppose my kind of high level thought, the other thought I would have is, I'd be surprised if any of our European fellow member states do any better, much significantly better than us. So if everybody has that level of fines, is everyone, are they all just going to come to an agreement? Okay, we've done our best, and let's just keep doing our best. So who knows? But there will be politics involved. Yeah,
space to watch. James, you've been involved in a lot of exciting projects across the States and Europe, but one in particular caught my eye. It was the development of a large-scale, state-of-the-art optimization model for the US electrical system that is now a key analysis tool of national and regional electric and climate policy options. That sounds fascinating in and of itself. Can you talk to me a little bit about that project, please?
Yeah, so that was, I suppose I built a mini version of such a model as part of my master's thesis at MIT, and the team at the Electric Power Research Institute had funding to build this tool. And so, I joined the team and some great people there, and we built it out. And it's, I subsequently went to do my doctorate next door at Stanford, and the team has continued to develop and do good work with the model. You know, it's the model is it's the sort of tool that's used in helping to calculate these targets, because it's like, should we aim for 20% reductions, or 50% reductions, or 30% reductions? So how do you come up with these numbers? And the models can help. And so you kind of you gather what you do is gather the data, try and get your understanding the existing state of the system, and then you have various projections, and then the optimization component is, okay, given all these constraints, what's the least cost way of getting where we would like to get to? And I find them, they're great tools, and they can be very insightful, but there is a danger they can be used as godlike authorities, and they're certainly not, because when you're in the weeds building them, you know all the assumptions. There's a lot of assumptions, so they're helpful tools. Um, what I would say about that model in particular, that was particularly cutting edge, was the treatment of variable renewables. And it's an important point on the technology, is that traditionally power systems have been designed around uh, dispatchable technologies. So on one side you had um, electricity demand, which was considered a given, like there was a certain shape to it, and on the other side you had the supply technologies. And traditionally was this model of, you had sort of baseload power, which around the world was typically coal, hydro, nuclear, and then so there would be high capital costs but low operation costs. And then for the sort of then there's all these periods where there'd be higher electricity demand, and it doesn't make economic sense to have a big expensive plant just running for a few hours a year. So then the tradition was, you'd have low capital cost, high operating cost plants meeting those hours, and that was typically at gas fired units. There's been some blurring of that over the years with gas prices coming down, and but my big point is, enter wind and solar, which you have different economics, where you had, at that point, you had high capital costs, zero operating costs. Now the capital costs have come down a lot, but it's this interesting element where they essentially, okay, there's various maintenance, but in the big picture they cost zero to run once they're built. But also you can't control them. Like, the wind blows when the wind blows, the sun shines when the sun shines. You can forecast these things. There are correlations with load. Um, but it's a fundamental change in how you plan a power system. To um, There was also a question, which has been largely solved by power electronics, was that wind turbines, for example, or how would they maintain the frequency of the grid? But the power electronics is an interface between the turbine and the grid, and that has kind of become a solved problem, which was also, there was question marks about as recently as 2010. Um, the Yes. So what I'd say, So what I want to say about, so on the model, what was important there was, we had some nice ways of treating and capturing those correlations between electricity demand, wind, and solar. And now, in recent years, there's been a big shift. Electricity demand is not this fixed thing. It's shaped as a moving target. And B, renewables have this, when they're available, they're free. uh, it's free in because they provide you, you've paid all this capital already. But when they're gone, they're not. They're not. You need something else. So it's so the model tried to capture all those things essentially. Yeah.
And when we look at the Irish grid per se, and I think, touching on your point there, the shift towards wider adoption of electrical driven appliances, be it heat pumps, vehicles, etc. So, is that creating a strain on the grid? Is the design of the grid fit for purpose, or do we need, very much like our water systems, to have a drastic rethink of how we create micro segmentation, that you have the likes of industry farms, places that have a lot of roof space, etc., running X amount of their daily load on solar per se, or wind sharing that with local community rather than feeding back into the grid? Do we need a rethink, or is the grid as it stands appropriate for that shift in peaks that we're now seeing with a move towards a more electrical driven future?
Yeah, it's a great question, and I suppose this is something that's been pressing on our minds after the recent storm Eowyn. And there's a large academic literature, and there's probably been a lot of demo pilot projects on microgrids, which essentially would be that where if the broader grid goes, you could have a little local grid could automatically kick into place, and there's a lot of elegance to that idea. I think there's a couple. Yeah, I think some vulnerabilities were shown after the recent storm, but I get the impression, like I can speak to some local experience where there's a line runs through a local forest, and everybody knows when there's a storm that line goes. So the vegetation when you look at the different options for making the grid more resilient, there's a lot of talk about undergrounding lines, changing the pole material from wood to steel or something. They're quite expensive. Like vegetation management is a lot cheaper. That would be that's where I'd start before a huge amount. And I think there has been talk about it, but that would be where I'd start. I think there is a very big point on the broader transmission system. So you have a separation between distribution grids, which bring power around our local communities, and then transmission grids, which can transfer power high voltage long distances. And if there was one thing from 2010, say when I look back and I think about what I was looking forward, I would be surprised. I am surprised. I would be surprised then that the transmission grid has not been built out faster, because there's a lot of numbers today that I hope I'm getting approximately right, but I'm not going to have exactly right off the top of my head. But I believe last year 12% of our wind power was spilled. Essentially, there was no.
When you say spill, James, you mean waste, as in and nowhere to put it because the grid can't handle the. Okay.
Yeah, and that number is increasing, and so every time new wind turbines are coming, that's happening, and basically it can't get out, and that's either it can't get out of its local area, its typical problem, or can't get out of the country. Now there's a big new interconnector to France under construction at the moment, which will help, but even within the local island, it's because when you look at the cost of transmission lines versus the cost of all these turbines and the cost of everything else in the power system, it's actually quite low. Like it makes the cost benefit analysis, the benefit to cost ratio is really high of transmission lines. And so I would have been surprised looking back. And there's some nice graphics from Scotland of recent weeks where there's all these wind farms in Scotland just turned off because they can't get the power down to London essentially. And it's like, yeah, there's lots of proposals, there's lots of talk, So that's the one that bugs me. That it's really sad to see, like, low carbon, zero cost marginal power, just being lost. So it's okay. It's only a fraction, but it's an increasing fraction, and it should be worked on. And then there's a market design element where, like, for example, in Britain and in Ireland there's one price for the whole country, but really at that time, say in Scotland, power in Scotland was free essentially because it was being spilled, while in London power is very expensive because because of these transmission blockages. So there's an argument that market design could incentivize, maybe make the transmission easier to build because of the dynamics and prices, but then you're weighing it against politicians perhaps very rightly saying, we don't want one part of our country having cheaper power than the other because that's going to create all sorts of problems. So it's like a lot of these. So where am I going with that is, the big theme is, again, I've mentioned 2010 a few times, but 2010, you're kind of building these models, simulating these systems, wondering what it's going to be like. Now we've kind of hit a point where they're happening to being built out, and there's technical solutions to some of these problems, and then there's kind of market design, regulatory, political solutions to just make it all work. Yeah. So again, I'm pretty positive, and things are moving in the right direction. But there's work to do still.
Do you see a level of innovation happening in the next couple of years? And when I look out at kind of the across the sea, I believe Japan, China have already started taking different approaches to electrical generation at almost a unit level. So what I mean by that is I've seen examples where they use people power. So people going through a train station, that door that you go through to enter the train is actually a mini wind turbine. That they're turning it and creating power from just people flow through these terminals. The floor plates are kinetic energy, so that the pressure of people standing on the floor or walking en masse is also generating power for these stations, etc. Ireland is very traditional in terms of we look wind and solar. Should we be thinking a little bit outside of the box? Should we be looking at high traffic areas such as roadways, such as shopping centres, hospitals, train stations, places where actually people can be part of the solution in terms of our general movement can actually create the output needed to generate electricity.
When you look at the big kind of grid perspective, a lot of those ideas seem expensive for relatively small gains. In a world where you could coordinate everything and build transmission, but in a world where you can't, it increases the value of those local initiatives. If you can't get the wind power from Scotland down to London, if you can, for whatever reason it's taking too long, if you can have your local generation in London on the tube station, it gets around. It's wonderful because it gets around all the years of delays. So that would be one perspective. So my family dairy farm recently installed solar panels, but one, going back to the agricultural sustainability, but like the role of the battery, seeing it in real time it really is so important. Again, that sort of local thing where in an ideal world, okay, you could, why need a battery? Someone else can use the power somewhere else in the grid. But the reality is that's getting all the market design, the price is right for that. It's simpler if you can just keep the power yourself and use it when the sun goes down. So it's those local initiatives are wonderful. And I'll mention China actually. So one thing they're doing in China that I learned recently, looking at some numbers, is they're still building a lot of hydropower, which we did the Shannon scheme in the 20s. There's actually a proposal in silver mines, which I didn't learn about until recently also. But so hydropower is this sort of thing where it can be terribly socially disruptive. So it's China has different dynamics. We'll put it that way, and they can build these things. The other thing that's striking in China is in Korea is their nuclear power build out is continuing, and like the new Korean nuclear plants, they're 4x cheaper than the power plant under construction in England at the moment, nuclear power plant, Hinkley Point, I think it's called. And I don't think the Koreans are compromising on safety there. That's a kind of South Korea is a developed, prosperous economy now. But it's just whatever factors, they're able to build a nuclear power for 4x softer. And I suppose that's the last part of your question, Francis. It's a question I'd ask all environmentalists, and it's like, what's your view on nuclear power? If you think climate change is the end of the world, maybe nuclear power is somewhere you want to think about too, because one of the fastest decarbonizations, if you look at the historical record, was when the French built out their nuclear fleet in the 70s and 80s. So it's at the moment, the problem with nuclear power is all the red tape with permitting and things. But once you get the permit for a nuclear power plant, it takes 15 years to build, it seems, in Europe. While if you get a permit for a wind plant, it's up in 2 years and operating. A solar plant, maybe even 1 year. So so nuclear has a lot. Yeah. So that's the okay. You have to. There's a lot of the local community has to have a lot of trust in the in the safety and things. So there's lots of challenges, and but personally, my kind of, probably in Ireland we were, Chernobyl, and it's nuclear power seems like a really bad idea. But like burning coal, like we did in Money Point, instead of building a nuclear plant in Carnshaw Point, like how many cases of asthma did that cause? Like it's not, it wasn't a zero cost solution. So there's lots of trade offs in all these things.
Yeah,
Yeah,
I think I watched a documentary, Bill Gates talking about this. I'd much rather live beside a nuclear plant with clean energy than a coal mine that, is polluting the air and, causing all sorts of societal issues for the people who live around it. So I think that is, again, a debate to have, but everyone's mind does go back to nuclear meltdown and all of the horror stories and the iodine tablets being sent out in the
yeah,
late 90s to every household in Ireland, just in
yeah.
case. That didn't help the hearts and minds of winning those conversations. So, yeah, really interesting, James. We're nearly up on time. I've just one last question to finish up on, if that's okay. You've studied at top institutes, so you mentioned MIT and Stanford, but you've engaged at very practical level in terms of engineering problems like machine fault prediction, etc. How do you translate cutting edge academic theory into solutions that actually make sense on the ground? What would your advice be?
Oh yeah, it's a great question, Francis. I so it was part of my journey was post Stanford to try and apply these mathematical models to like real projects in terms of, instead of planning policy for the next 30 years, but actual, can we build a tool that can make money now or make something more efficient now? Yeah, there's different angles, but I suppose I'd say what I found useful is listening. Is, you can't just be getting out on the ground and talking to people who are doing the work and trying to understand the actual problems, and you try and you bring your kind of knowledge of the academic work and try and you kind of do this mental mapping between the problems on the ground and what the tools can possibly help with. And that's, yeah, so that's I found that's the approach I followed, and it has worked pretty well. I might just mention one of my latest tools is with a colleague, Roland McGovern, is to try and help speed up the permitting process using these wave of large language models to try and help with all the paperwork. So I prefer the numbers, but sometimes the paperwork is the blocker. So we're trying to see, can we try and move the needle there too.
You're going to sell it to Dodge?
Well, I think the US market has been decimated in the last few weeks. I think environmental impact assessments in the States are going to go from 5,000 pages to 5 pages. And yeah.
We won't open that can of worms. So, James, look, it was really nice having you on. Thanks a million for taking the time to sit down.
Thanks so much, Francis. Great to talk to you.
Thank you.